Hi guys, Bill Trombley from Trombley Tool in East Troy, Wisconsin. Today we're going to talk about using thumbnail dies in a Pullmax, or a Pullmax style machine. So video number one was using thumbnail die techniques. I did that work in a power hammer. Some guys had posed some questions on doing the same technique in a Pullmax style machine. So my machine is actually a Trump machine. It's a CN 900, which is the biggest one that they make. It's a machine I bought a number of years ago and went through it and fully cleaned it up and restored it. Before this machine, I had a Nibbler medium, and that machine worked awesome. So all of these techniques and ideas transfer to any style of reciprocating machine. So there are a few things that's important to know when setting it up in a Pullmax style. But we'll just go through the basics first. So today I'm going to just use this piece of material here. So this is 2024O, which is an aircraft grade structural material that would need to be heat treated after we shaped it. This is 50 thousandths thick, and it's 8 inches long. And this is just a basic test coupon. And if we go back to the techniques, the first technique would be is to put a curve in this panel like this. So that's technique number one. And then technique number two was how we maintain it with die alignment. You know, so whether the back of the panel is too low or too high. That was technique number two. Now, if you look online and you see comments about thumbnail dies, a lot of people say is, well, you just got to pull down on it. You know, when you're coming out, just pull down on it. Okay, but how much? That's the kind of the tricky part of it, I guess. So if you pull down on it too much, then what happens is the die clearance isn't proper anymore, and that's where a lot of the tool marking comes from. So in my opinion, the best thing to do is pull down on it where you're staying level going through the die. We talked about that more in the first video. So that was the condition of technique number two was the alignment. Technique number three was RPM. So we had talked about in the power hammer about the importance of an RPM. But how does that reflect into a Pullmax? And this was one of the questions that popped up, is what's a good recommended RPM? Well, on my machine here, I have a digital tachometer and a variable speed clutch. So I can vary my RPM. So I have this set at 2,000 RPM, which equals 2,000 hits per minute. In my power hammer, that runs at 1,000 hits per minute. That I know, I checked with a handheld tachometer as well. So what's a good speed? I don't know, somewhere between 2,000 and 1,000 RPM. What happens if you go too slow in RPM? There's a machine up in Minnesota that is a hand-built machine, or a dedicated shrinking machine. And they had me look at it, and I was working with some guys. And in order for them to get it so that it had enough momentum to cause the shrink, they had to put a gear reduction in it. And that hits, and this is a total estimate, maybe 600 hits per minute. To me, that seemed to be too slow. And the reason why is you had to then slow down your feed rate to account for the hits per minute. So I wouldn't go that slow. So is going higher than 2,000 RPM beneficial? Probably not. I don't know what you would gain from it. You know, 2,000 RPM, that's moving pretty good. And you gotta remember, this is an offset that's unit in here, and if you offset that a lot, well then that will cause the machine to shake because of the increased RPM. So 1,000 to 2,000 hits per minute is great. On Pullmax machines, they are known for having a double hit, which means that when the die comes down, it actually slightly floats up and then goes down again and then returns. So even though they're hitting at 1,000 RPM, Pullmax says it's a 2,000 hits per minute. and that's how they're doing it. So it's 2 hits per every revolution. So, you know, weigh that into it, I suppose. So that's what's important as well. Feed rate we talked about in the first video, and that still applies to this. And then there's 2 other adjustments in a Pullmax that you can make that isn't exactly the same as it is in a power hammer. So the first adjustment is how far this reciprocates up and down, the stroke length. So on this machine, that's adjustable. And I'll take this video or camera and we'll go over here like this. So underneath this door right here, if I pull this collar out, whoops, like that, I can change my stroke setting from 1 millimeter all the way up to 10 millimeters. For each time this rotates, how far this moves down and back up. And that's common on, I think, most all reciprocating machines probably. You could adjust that. I have mine set at 5 millimeters. So why is that important? Well, I can go all the way down to 1 millimeter per stroke. And what will happen is if the stroke length is too short, so when the stroke comes down and it comes up, you then have to take and advance the material. And then it comes down and it closes the tuck again. And then it comes up and then you advance the material. And it comes down and closes the tuck. Well, if it's only going up and down 1 millimeter, which is 39 thousandths, as you're going in, it'll feed in fine. But when you're going out and it's gathering the tuck, you'll feel resistance on the panel as you're trying to pull it out. And you can do it, you know, it'll push through it, but you're not necessarily gaining much. The surface finish quality might be a little bit better, but we'll see how well it is with this. But if I went to 10 millimeter stroke, which this machine would do, so now it's going up and down 10 millimeters, which is 393 thousandths. That is a large amount that it goes up. Well, in that amount of time that is moving up and then moving back down, I'm moving the panel. So what happens then is it's easier to see the individual hammer blows. And that's because you're advancing the material in between the blows. So RPM helps with that, but also the stroke height. So 5 millimeters seems to be work pretty good for my setup. So that's one important thing that's different with a Pullmax style. The other one is the shut height. So on my machine, I have an electric up and down motor on this unit. So I'm going to bring this all the way down until it stops. So this is the bottom of how the distance of my ram goes down. So like on some of the Pullmaxes or my Nibbler medium, there was a lever on the side and you bring that all the way down, and that's what I did. But now I got to set the shut height, and then what I have is an adjuster wheel down below. And I've already preset this one. So this 50 thousandths material, and you can see I can slide it in there. And my tool gap here is a couple thousandths of an inch. Maybe 3 thousandths or 4 or 5 thousandths of an inch. And how I know that is I can take this and run this through with the hand wheel on the side. You can see this move up and move down. So you run it all the way down and then bring in the material. Now it's important to have the gap, in my opinion, and this is why. The material, you got to have room for the dies not to be touching. This is a steel die and a steel die. And so if this is a negative clearance, it's like a hammer-on dolly technique, right? What happens? The stretch will occur. So if you have this where it's a negative clearance, now you're going to have a stretch that's occurring in the shrink area. So leaving the gap of a few thousandths is a beneficial thing to have. The other thing that's important is, this is a part I made for a Fairchild 24, which is a 1946 Fairchild 24, and this is a wheel brake cover. So it's a streamlined fairing. And I did this with a little bit of stretch in the center, and then all of this was shrunk using thumbnail dies. And as this goes around, and as this becomes and gets thicker and thicker and thicker and thicker, you have to have room for the material to go. So that's why you want to have the clearance in the die. Now this is a big fundamental difference that exists between using a Pullmax machine and a power hammer machine. So as this gains in thickness, this is a fixed stroke machine, meaning that when this comes down, that shut height is exactly the same every single time. In a power hammer, it's not. In a power hammer, there's a spring in the circuit. So on a Pettingill, Yoder, Mittler Brothers style power hammer, there's a leaf spring assembly, and it has these two links on it. They call that a bow link style. There's a guy out on the West Coast, his name's Bobby Walden. I've never met him. He has a great YouTube series, and he's a power hammer guy with a Yoder, and he was the one that was talking about the bow link design with the leaf spring. And you should go watch his videos. It looks like really great stuff that he's doing. In a Bailey industrial unit, and those are the brand new machines that are made nowadays, and I don't own one. I've used one once, but I have some friends that have them, a number of guys. And in there's a spring as well. And I think they're using a die spring assemblies in there to create it, but it's still a spring. So the benefit is as this gains in material thickness, the dies automatically compensate for that. And in a perfect world, we want this that, in a high crown panel like this, that it's thinner here and it's continually increasing in thickness as you get out to the edge. And I know this to be true because I can take my measuring tool here and I can measure the thickness gain. This piece here is a 40 thousandths piece of aluminum here, and it's 50 thousandths up here. That's how much it gained in thickness. So in a Pullmax, what happens is if you're shaping, and you'll see this a lot-ish, is as this gains in thickness, eventually what will happen is you'll run out of die clearance and you'll start seeing blowing the material out of the backside of the edge. And some guys go, well, so what? You just, trim it off. And I agree. That's perfectly fine. But for me, as an airplane guy, I want to increase the thickness. I would rather be taking the material and utilizing it, increasing thickness, than just taking and cutting it off. So how would I do that in a Pullmax? Well, I set my die clearance, so there's a couple thousandths clearance, and as I begin to shape, if I notice that the material is starting to push out the back edge, I open up the die clearance a couple more thousandths. Now on this panel here, this grew 10 thousandths in thickness from here to here. So that's 10 thousandths. So to open up the gap a few thousandths, it's not a big deal. And then you're giving that the place to go. If the die clearance is too open, what you'll see is instead of a nice flat area, is you'll see a remnants of the tuck. It'll be just this lower profile area. That's not a problem either. That you can easily plenish out. Is it a little bit less efficient? Maybe, but it's still very effective. So setting your shut height is important before you start, because you don't want this to be negative clearance. And not only will it cause a stretch in the material, it's also hard on the machine, in my opinion, and a lot of guys see it that way, is because this has to over center with like a connecting rod or a crankshaft in a car engine, and then a connecting rod coming down. Well, if that's negative clearance, now that's popping over that. And would I wreck the unit in this big of a machine? Probably not. But why beat it up either? So that's an important thing. So what we're talking about then is shut height and how to properly set that. So what we discussed so far, I'm going to close the side door, is put the rate form in the panel, RPM, so my machine's at 2000 RPM, offset 5 millimeters, right? Feed rate, how I feed in and out, we'll go slow with it. And then the shut height is set, and shut height is set, and the one other thing that I was talking about, RPM. Well, anyways, so there we go. So what I'm going to do, actually, for this piece here, is I'm going to time it, and we're going to run it for 2 minutes. And there's an important reason why. So I'm going to use my wristwatch, and I'm going to time this. And these are steel-on-steel dies. These are not plastic, and that's also intentional. It's to show that it can be done, that it's not that me using the plastic dies was somehow cheating or allowing me to get some unobtainable result. So steel-on-steel dies, and we're going to run for 2 minutes. So I'm going to start this, and we're going to go. 1 minute. That's 2 minutes. So the reason for the demonstration, one, you can see the panels moving around. Well, it's a pretty small panel. You know, it's 8 inches by 4. So it's hard to hold on to. So that's one of the things. If it was a bigger piece, you would barely see it move at all. But I wanted to do this demonstration to show you the effectiveness of thumbnail die shrinking. Now, this panel is pretty warm, and that's because of all the material I collected. Now, if you look at the surface finish of this, and I'll bring this light over, like that. Look at the surface finish. Pretty damn good looking piece. You know, bottom side. Very efficient, very clean looking, nice looking part. With a piece like this, I could plenish this and ship it. That's how good the part looks. Is that efficient? Well, I have this flexible tape measure here, or flexible ruler. So in this area here, it's an 8-inch panel, the non-shrunk area. In the shrunk area, let's see here, how did I do? Seven and a half. So I took up a 1/2 inch of material in 2 minutes. Pretty damn efficient. Is this panel hard? You know, that's one of the questions that thumbnail dyes will harden the surface, and it just wrecks everything. Nope. Not hard at all. So you can see how well the process works. And 2024 is not a fun material to work in. 2024 aluminum is the structural grade aluminum that we use for building airplanes. You know, and probably 98% of all airplanes flying around is made out of 2024 aluminum. So very efficient, very clean looking process. Is there anything that's special here? No, it's technique. So learn the technique, and it's important. One of the things that's important to do, and I'm going to tell a short story. One morning I come into the shop and we have a rush welding job. So I go over to the welder and I fire it up and I begin the welding, and it's vaporizing the tungsten. And I'm just, you know, I got to get the job out the door, and I'm having trouble. So there's another weld shop here on the airport. I went up there and borrowed their Miller welder. There's a Miller Dynasty 260 or whatever. I'm not a Miller guy really. And I brought it down here and I was able to get the job done. And once the job was done, I'm sitting there in kind of disgust, because I'm looking at this, and I don't want to have to invest in a new welder. You know, I'm not a big fan of some of the other welders that are on the market, and I don't want to put the money into it right now. You know, and it's just, you know, you're feeling pretty low. And all of a sudden I'm looking at it, and I look at his settings, and his settings are different than where mine is at. So I take my welder and I reset all my settings, and I fire up my machine, and it just welds beautifully. And I asked one of the guys in the shop, I go, hey, did you change these settings? And he goes, yeah. I go, why? He said, this is why I thought it would make it run better. I said, did it? He goes, no, because it made it way worse. It's a valuable lesson in that. Now, I'm happy that he's experimented and that he tries. That's how we learn, right? You have it, see where this goes. But I didn't know that he changed it. One of the funny things is I'll go around and I'll talk to other professional welders, and I go, how often do you change their settings? They go, never. You know, how often do I change the settings on my welder? Seldom. You know, I mean, there's some small adjustments we make, but not huge adjustments. So why is that valuable? So if you look over by our welder, hanging on the wall is some basic notes. They're basic parameters. And I put this up after I had that issue. That way, if I'm using the machine and I have an issue, I can look on the wall and go, oh, look at that, you know, and reset it and just keep on going. I have a sheet like this over by the power hammer. And what that tells me is what my offset should be, my die height should be, my speed should be, because I got a variable RPM motor on my power hammer. And that way I can just go to town. You know, I have that here for this Pullmax. It's a smaller sheet, but same information. It's stuck on the side of the machine with a magnet. Now, these thumbnail dies, or any thumbnail dies in my Pullmax here, this Trump machine, I haven't used in a year. You know, why? I have a power hammer. So I don't use this much for thumbnail die shrinking. But here it is, it's a Sunday afternoon, I decided I'm going to do a video. So I pull this cheat sheet and I look down and I preset my machine. fire it up and I shoot a video and I make this. No practice, no, I don't know, or, you know, got 10 pieces of scrap pieces to do this before I get a good one. None of that, right? Quick, clean, and efficient. The benefit of that is it creates consistency. So what it is each time I shape with this, it's a consistent result, consistent result, consistent result. If all of a sudden it's non-consistent, I can instantly look at it and try to figure out why, right? Maybe the die moved. You know, maybe I didn't follow one of these things and I got something set wrong. Maybe I'm trying to shrink a different kind of material. I don't know. But that makes it easy and quick for me to identify the issue, address it, and fix it, and move forward. You know, metal shaping is hard enough as it is. So variables that you can easily control them. So how do you do it? Experiment, right? These are basic parameters, but would my offsets and my numbers work for you? Probably not. It would be like me trying to buy the same kind of golf clubs that Tiger Woods used. Am I going to become a Tiger Woods golfer? No, right? So it's the same thing. So how do you do it? Take a scrap piece of material that you know is this grade and you know it's this thickness, and work through the parameters, right? These techniques I showed you and that we talked about, and the tuning of the dies, you know. Did I tune these dies? Yeah, like that much, you know, like. And would it matter? No. You know, so don't get hung up on that. But then do a test piece and be analytical and honest. And what is it that you see and how is that working? And once you get it like dialed in, like, man, that's what I want. You know, like this shut height. If it bothers you, or you know, like, I don't know if I could tell 5/1000 of an inch, set it up with a feeler gauge. You know, and by these parameters, right, they're simple. Then for me, I just wrote it in a Word document, stick it in a sheet protector, and magnetically stick it onto the cabinet over there by my power hammer, on the wall over by the welder, right? And then that way, then it's like, poof, I just go in there and I set, and I run. And it makes it efficient shaping. And it takes the frustration out of it. It allows you to get this accurate, consistent result every single time. And when it doesn't, it immediately points that there must be a problem. And then you can go in there and start fine-tuning it and find where is this issue and fix it. So I highly encourage you to do that. It takes no extra time, and in the long run, it really pays off well because it's so much faster. You know, the setup in this was nothing. Pretty damn quick. So I think that's a good jumping off point. You know, no secret sauce here, no film editing. You know, that 2 minutes was 2 minutes. No flashing lights, no extra music to go with it. You saw me do it. So please let me know what you think, and like, subscribe, tell all your friends, and thank you for the support I've been given. It's been incredible. So thanks, and have a good day.